Example number 7, draw the shear and moment diagram for the beam shown in the figure. For the reaction of the support, since we have here cantilever beam, we have the vertical reaction at point A. If this is point A, and of course the end of this uniformly distributed load is the point B, and this is the point C. We have here the AY, AX, and of course the moment at A. For the resultants of this uniformly distributed load here, it is just the area of the rectangle. We have the length of 4 and the magnitude of 60, so that's 4 times 60, and this is equal to 240 kilonewton. So let's solve for the reaction of the supports. If we are going to summate forces horizontal is equal to 0, taking the direction to the right as positive, then we have here AX is equal to 0 kasi wala naman siyang kalakal. And summation of moment at point A is equal to 0, taking the clockwise direction as positive. Then we have here the moment at A, we assume that it is counterclockwise, so that is negative. And this 240 kilonewton here will rotate clockwise, so it's positive 240 multiplied by the moment arm. The moment arm is just half of this 4 here, so that's 2. And this 265 here will create a clockwise rotation, so that's positive 265 multiplied by the distance of 6 meters. And this couple here at the free end, which is 1350 kilonewton meter. So that's positive because it is clockwise, and this is equal to 0. So solving for the value of the moment at A, that is equal to negative moment at A plus 240 times 2 plus 265 times 6 plus 1350 is equal to 0. Shift solve equals, and we have here 3, 4, 20. So we have 3, 4, 20 kilonewton meter. And if we are going to summate forces vertical is equal to 0, taking the upward direction as positive, we have here the AY, assume directed upward, so that's positive. This 240 here is downward, so it's negative 240. We have the 265 here downward, so that's negative 265. And itong couple na to ay hindi kasama kasi we are summating forces vertical, so this can only be considered here in summating for the moment, and this is equal to 0. So AY is equal to 240 plus 265, and that is equal to 505. So this is 505 kilonewton. So AY is equal to 505, and this moment at A here is equal We have here 505 directed upward, and we have here 3420 directed counterclockwise. And for the resultant of the load here, we have 60 multiplied by the distance x, and it can be found at half of the distance x. Now from the section, this is x over 2. Since we cut somewhere here, then na-expose natin yung shear and yung moment. So for the shear equation, we have the shear is equal to 505 directed upward minus 60x. So at x is equal to 0 and x is equal to 4, let's solve for the value of the shear at 0 and the shear at 4. So if x is 0, of course, that is equal to 505 kilonewton. And if x is 4, so we have here 505 minus 60x. Calc 4, and we have here 265. So this is 265 kilonewton. Ayan. Patapusin natin yung tuko. Yeah. So we have for the moment. So for the moment, we have here 505 times x, and that's 505 times x, and this 60 here will create counterclockwise. So that is negative 60 multiplied by the distance of x over 2. And this 3420 here is counterclockwise, so it's negative 3420. So for the moment, we have here, I'm sorry, this is 60x. So we have here 505x minus 60 divided by 2 is 30. That's x squared minus 3420. So at x is equal to 0 and x is equal to 4, let's compute for the moment at 0 and the moment at 4. So what we are going to do here is, of course, to substitute 0 at the equation, so 0, 0, and this is negative 3420 kilonewton meter. And let's check kung ano yung moment natin at 4. So we have here 505x minus 30 x squared minus 3420, and calc 4. We have negative 1880. So this is negative 1880 kilonewton meter. Now, for checking, we take the derivative of the moment function, and so the derivative of the moment with respect to x is the shear. The derivative of 505x is 505, and the derivative of this negative 30x squared here is negative 60x. Okay, the derivative of the constant is 0. So this is correct kasi napalabas natin yung ating shear function. Okay? So, i-draw na natin simultaneously yung ating shear and moment diagram from the computed values. Okay. For the shear diagram, we have at x is equal to 0, the moment is 505. So, we have here 505. And at x is equal to 4, that is equal to 265. So, 265. Now, as you can see here, for our load, we have degree 0 here, so we're expecting degree 1 in our shear diagram, so this is just a line. So let's connect the 505 to 265 using a line. Yeah. Okay, so how about in the moment diagram? So at x is equal to 0, that is negative 3420. So in here, we have negative 3420. And At x is equal to 4, we have negative 1880. So in here, we have negative 1880. Okay, so since our shear diagram here is decreasing, so we will apply the idea of the dy/ix. So decreasing, bibend natin yung y-axis. No? So in this case, if this is the origin, this is the y-axis. So bibend natin yung y-axis. This is degree 1, so we're expecting degree 2 curve here. So this is the curvature. And we have here a degree 2 curve. Okay, so this is our moment diagram for the segment AB. And for the segment BC, we have the limit from 4 to 6. So this is 4 less than or equal to x less than or equal to 6. Okay, so ito yung segment, ito yung section natin. We have this uniformly distributed load over the span of 4 meters, and this is yung cut. Yan. Okay, so for the reaction, we have here 505 directed upward, and we have 3420 counterclockwise. Now, so for the resultant of the load, we have here 240 acting at 2 meters from here and 2 meters from here. And at the section, so we have here x, and the location of the resultant nitong load na to can be found at x minus 2. Of course, we exposed here the shear and the moment. Okay, so for the equation of the shear, we have the shear is equal to 505 minus 240. So since dalawa lang naman sila yun nandyan, and this is equal to 505 minus 240, that is 265. So we have here 265. No? So this is the equation of the shear. At x is equal to 4, yung shear natin at 4 is 265 since constant lang dyan. And x is equal to 6, still our shear here 265 since constant lang. How about the moment? So for the moment, we have here 505 multiplied by the distance x, then minus 240 counterclockwise, multiplied by the distance of x minus 2 from the cutting section, and the negative 3420 here counterclockwise kasi siya. So simplifying the equation of the moment, and we have here, okay, so we have here 505x minus 240x plus 240 times 2, so that's 480 minus 3420. So simplifying further, and we have here the moment is equal to 505 minus 240, that is 265x, minus, since we have 480 here, minus 3420, and that is 2940. So this is 2940. And at x is equal to 4 and x is equal to 6, let's compute for the moment at 4 and the moment at 6. So we have here our equation 265x minus 2940. So calc 4, and we have here negative 1880. So negative 1880 kilonewton meter. So that's a sort of our checking, since nagmatch siya doon sa previous natin na sagot. Calc 6, and we have here negative 1350. So we have negative 1350 kilonewton meter. Now, if we are going to check our shear equation from the moment equation, which is equal to 265x minus 2940. Then we have here the shear as 265 since the derivative of 265x is 265 and this is 0. Okay, so at x is equal to 4, ang moment natin ay 265 and then 265 din siya ng 6. So we just have here a constant, no? So line lang to. And kung titingnan natin yung load diagram natin, we have this 265 downward. So, kung meron ka ditong 265 and 265 downward, siya yung magsasara ng ating shear diagram. No? So, this is now our shear diagram. How about for the moment? For the moment, we have negative 1880 and then we have negative 1350. So, in here, we have negative 1350. So, since this is just equation of a line, no? And kung titingnan natin dito, this is degree 0 kasi. So, we're expecting degree 1 here. So, kukonect lang natin itong 1880 to 1350 using a line. So, this is just a line, no? Degree 1. And this is our moment diagram. So, paano magsasara yung moment diagram natin since we have here 1350? And kung titingnan natin dito, we have applied couple of 1350 positive. So, ito ay iaakit niya to 0. So, magko-close na yung ating moment diagram dito. Okay, so ano yung mga possible questions natin dito? Of course, the maximum positive shear is equal to 505 and the maximum moment naman is negative 3420. So, solve natin to using the area method for our next video.